The best way to look at Earth is from outer space. Modern systems for observing Earth are nothing more than a contemporary way of doing what people have been doing throughout time: gazing into the distance. Humans, like animals, quickly understood the higher one climbed, the more one could see. By hoisting himself up, the watchman searches the horizon in an attempt to discover what is hidden from observers on the ground. The invention of the balloon gave birth to remote sensing. Observers could climb thousands of meters or fly over inaccessible areas to look down on what had been until then impossible to see. Battlefields, especially movements of troops, were observed, thereby completely changing military strategy in the 18th century. The invention of photography 100 years later further enhanced aerial observation. It froze images and allowed them to be studied later at one's leisure. When airplanes replaced balloons, they offered even more freedom to observers. With the invention of rockets capable of reaching higher and higher, aerial photography of the Earth moved beyond the atmosphere.
Oh, that view is tremendous.
Today, there is no limit from which we can view Earth. Remote sensing has become a complex science which can be used to prepare detailed surveys of large forested areas, to evaluate the precise productivity of certain agricultural regions, and to monitor changes in cloud formations, to forecast weather. Meteorologists quickly discovered the potential offered by observation by satellite. In 1960, the Americans launched the first experimental weather satellite, TIROS-1. In orbit 750 kilometers above Earth, the satellite's TV camera provided the first astonishing images of cloud cover over Earth. This satellite was the first in a series of machines which were to succeed one another in space. From the very start, the observations recorded by these satellites were offered to every country in the world. This program was the first real step in cooperation in space. These continually relayed pictures enabled meteorologists to follow changes in cloud formation and predict impending storms. Meteorological satellites have become more and more sophisticated. Orbits have been adjusted so that satellites fly over specific regions, allowing them to benefit from their position in relation to the sun. Televised pictures have always been one of the most basic elements in meteorological observation. New instruments have enabled meteorologists to measure other types of information, such as temperature and humidity of different atmospheric layers. The space shuttle is used to launch such satellites. In October 1984, the Space Shuttle Challenger sent up the last in a series of 3 satellites designed to measure the quantity of heat absorbed and released throughout the Earth's atmosphere. As a result of such data, meteorologists will eventually be able to construct more precise models. A few years ago, the number of low-orbit satellites was doubled. A network of geostationary satellites, which provide a fixed image of the Earth's entire atmosphere, was added by the United States, Europe, and Japan. Towards the end of the 70s, these satellites, even the ones from the Soviet Meteor series, were used to gather the most comprehensive data ever compiled about worldwide meteorological conditions. This information serves as a database for developing mathematical models which allow us to increase the scope and accuracy of meteorological forecasts. But satellites are not just used to observe clouds. Their analytic instruments can also be directed towards the Earth. Known as remote sensing, this application is quite recent. The first real remote sensing satellite, Landsat-1, was launched in the summer of 1972. It was followed by a series of 4 other satellites, each with improved technology. The satellites in the Landsat series have, to date, supplied more than 1.5 million pictures from all around the world. These photos are formed like a television image. They assemble millions of points by scanning the Earth's surface. Each image transmitted by the latest generation of Landsat satellites contains more than 300 million points, each of which represents 30 square meters of the Earth's surface. The luminosity of each of these points is carefully measured and recorded in artificial colors, making the pictures easier to read. The pictures contain so much information that they cannot be stored in the satellite and must be constantly relayed back to Earth. The mathematical and computer analysis of remote sensing pictures produces vast quantities of information. It can be used to predict harvests or report on progress in drought-ridden areas. Photos of forested areas can be used to calculate the eventual production of wood, as well as the forest's health. Other pictures reveal to prospectors the geological characteristics of an area, the nature of the subsoil, and the possible existence of minerals. Clearly, these images represent a source of information which is extremely important, both strategically and economically. The data collected by the first Landsat satellites were made available to anyone who wanted to use them. This openness is coming to an end. The Landsat system has been turned over to a private company, which intends to operate it on a commercial basis. This transformation was carried out in 1984. There were problems, and the availability of pictures was severely disrupted. The privatization of the Landsat system occurred at the same time as a competing remote sensing network was being set up in France. The first satellite in the SPOT system was sent into orbit in early 1986 by an Ariane rocket. Unlike its American counterpart, the SPOT system was conceived as an integrated commercial enterprise from the very beginning. The system uses 2 satellites and several ground receiving stations. The commercial infrastructure for distributing SPOT images is already in place. It intends to serve clients all over the world, starting with the United States. The American and French remote sensing systems compete with one another on the international market, and it seems the American Landsat will have trouble as a result of the new organization. On a technical level, the SPOT satellites have certain advantages over their American competitors. From their orbiting altitude of more than 800 kilometers, they'll be able to sense details smaller than 10 meters. The satellites orbit the Earth in exactly 101 minutes and can point their sensors on either side of their trajectory. This special feature makes it possible to re-photograph the same point on the planet within the 2 days essential for certain environmental applications. These double photographs also allow for stereoscopic images of the Earth's surface, which provide several interesting views, particularly to geologists. The wide availability of these pictures should open the door to new fields of application where remote sensing will be key rather than merely experimental. Conventional remote sensing satellites, however, are hindered by cloud cover, which often conceals the zones under examination. One solution to this problem is radar. The advantage of using radar to observe the Earth is that it works both day and night and is virtually unaffected by bad weather. This method of observation is more complex, especially when it comes to high precision observation. The first Earth observation radar was placed in orbit in 1978. This experimental satellite, known as CSAT, functioned for only 3 months, but it produced results which surpassed the expectations of the designers themselves. One of its most spectacular observations was of the sea. By carefully mapping the surface of the water, the satellite revealed the topography of the sea bottom. In turn, this information led to improved knowledge of the Earth's crust and its evolution. The radar images also provide information about short-term phenomena, such as the erosion or drying out of the soil, and of the evolution of ice coverings on the oceans. The strategic implications of this type of instrument are obvious. Radar of this kind can trace the movement of submarines traveling along the ocean floor as easily as though the ships were on its surface. This was probably the type of experiment the American Navy was carrying out with its satellite GeoSat, which was designed along the lines of CSAT and launched in 1984. The technology developed for CSAT has had many opportunities to prove itself. 2 similar radar satellites were on board the American Space Shuttle during its 1981 and 1984 missions. The shuttle itself played the role of a satellite observing the Earth. The most surprising pictures collected were of the Sahara Desert. In a region where there seemed to be nothing but sand, the SIR radars found traces of dried-up rivers and the sites of long-lost civilizations. CSAT inspired many countries to build their own equipment. This equipment should soon be in service. India and Japan are building these satellites. NASA is developing the TOPEX project, and the European Space Agency plans to launch an ERS-1 satellite by the end of the 90s. They will use it to survey oceans and coastlines. A RadarSat satellite is being developed in Canada and should be in service in the early 90s. Placed at an altitude of 1,000 kilometers, it'll be able to cover the entire globe in 16 days. Its radar will be able to cut through clouds, snow, and darkness to distinguish details on the ground as small or smaller than 25 meters. RadarSat will be used to improve the management of agriculture and natural resources, and to survey polar ice fields. This is particularly important to countries like Canada, which have considerable maritime traffic in their Arctic regions. Aerial remote sensing can also be used for espionage. Spy planes, such as U-2s, were initially used for such missions. Detailed aerial pictures helped American authorities to force the Soviets to withdraw their missiles from Cuba in 1962. Satellites are increasingly replacing spy planes because they are more discreet and less vulnerable.
The following aerial photographs, most of them secret until now, illustrate this.
More than 20 years after the Cuban Missile Crisis, President Reagan used images obtained by satellite to denounce the militarization of Nicaragua and to justify the invasion of
Acres
Grenada.
and acres of antenna fields and intelligence monitors are targeted on key U.S. military installations and sensitive activities.
It is said that only pictures of poor quality taken by spy satellites are made public, and that the best results remain hidden. It's generally accepted these satellites can provide extremely detailed pictures of a few centimeters. It was also claimed that pictures taken by these satellites during demonstrations in Iran made it possible to identify the individual ayatollahs there by the shape of their beards. Like standard satellites, military satellites can be reached and refueled by the shuttle. At the same time, astronauts can recover precious film and reload the spy cameras. The shuttle can be used to transport heavier and more sophisticated observation equipment. Such missions were carried out in January and October of 1985. The American authorities would not, however, reveal the purpose of these missions. It seems that Earth's mysteries can be better understood from space. The ability to look down from on high increases the dominance of more powerful countries over countries which don't have access to the best technology. This is true both militarily and economically, particularly in cases where underdeveloped nations depend on developed ones. Unfortunately, those who have penetrated the secrets of our planet have failed to show a willingness to pass on their knowledge to the world community.
Dat kleine beetje had een naam en heette
Morgen komt Maya erbij, samen met